Hello everyone, welcome to the first part of the ZPY tutorial series. My name is Hugo and I am one of the co-founders at Zumo Labs. Zumo Labs generates synthetic training data for computer vision models. Find out more about us at zumolabs.ai. Feel free to email us at founders@zumolabs.ai. So in this video we are going to be creating a simple Blender scene. Then, in less than 100 lines of code, we are going to script the scene with Python and ZPY. And from that script, we are going to generate a small synthetic data set for the task of object detection and segmentation. And let's go ahead and get started. So, first thing we're going to do here is open up a Blender scene. So, Blender is a 3D program for content creation. This Blender already has ZPY installed. If you do not have ZPY installed or Blender downloaded, please go ahead and pause this video and go to the link below and download ZPY and follow the install instructions on our GitHub to get yourself set up with Blender and ZPY. Okay, so now that you have ZPY installed on Blender, we're going to go ahead and get started. So this is the default Blender scene here. We see the default cube, and we're going to go ahead and do the cardinal sin and delete this default cube, and instead let's use the monkey. So Shift-A to add, and then let's add a monkey. This is Suzanne, the famous Blender monkey, and we're going to create a data set of Suzanne so that we can detect Suzanne in real life. Stay tuned for later parts of the tutorial series where we will go through the whole machine learning process. This is simply just the first part, using ZPY to generate the synthetic data set. So we have our monkey, we have our camera staring at the monkey. You can actually click on the camera and then click on this little toggle the camera view, and that actually shows you what the camera is seeing. So now we have our monkey, we have our camera. I think the next part is we want to go to the scripting tab. So Blender provides a kind of little mini IDE that you can create Python scripts and run these Python scripts, as well as a Python console, right? So you could say 2 + 2 here, that's 4, of course. So let's go ahead and make a new script here, and let's call it run. So this run script, let's go ahead and import bpy, import zpy. So bpy is Blender's Python library, and zpy is Zumo Labs' Python library, which is open source and available on GitHub. Check the comments for the link. So first thing we're going to do here is define a run function with a num images argument, let's say 10. So we're going to generate 10 synthetic images from this run function, and here's where we're going to do these thing. So if you've written some Python before, you know this particular little piece of code here. If name equals main, run. And what that's going to do is it's going to basically execute this run function whenever you run this script. So whenever you run this script, it's going to import bpy, then it's going to import zpy, then it's going to say, oh, okay, there's this run function, and then it's going to get to here, and it's going to say, ah, yes, my name is main, and I will run this run function. Okay, so now let's go back to the run function here, and first thing we're going to do is we're going to make a saver object. So let's go ahead and say saver equals zpy.saver.image_saver. And let's give this a description. Say monkey dataset. So saver is an object which will store all the images and the annotations and allow us to link annotations and images. ZPY provides a couple different types of savers. In this case, we're going to be using an image saver because we want to be making a detection and segmentation dataset for images. All right, so now that we have the saver object, let's make a little handle for our monkey. So our monkey here is zpy.data.objects. So Blender allows you to go and reference objects that exist in your simulation, in your Blender scene, by their name. So our monkey here is called Suzanne. So if we go to the outliner, we see that the name of the monkey is Suzanne. The object is called Suzanne. So we're going to go ahead and say that this object, the one called Suzanne, we're going to give it this simple, we're going to save it as a Python variable here for convenience. All right, so now we have our saver object, we have the monkey object. Let's go ahead and add the monkey category, right? So we're going to want to create segmentation images for this monkey. So to do that, we're going to have to create a category called monkey, and we're going to have to define a color for that. So let's go ahead and say monkey seg color, and we will define some random color for this. Let's say 0.2, 0.1, 0.9. I do not know what that is. Has a lot of, this is an RGB, so red, green, blue. So there's a lot of blue, not a lot of green, and not a lot of red. So it's probably going to be mostly bluish. So now that we've picked our segmentation color, let's go ahead and add a category that is monkey. So that's the name of our category. And the color is going to be the monkey segmentation color. All right, so now we've got a handle to the monkey, we've gone ahead and defined the color, and we've gone ahead and added that category to our saver object. So now let's actually segment the monkey object. So we provide a simple call here. You can say zpy.objects.segment, and we're going to go ahead and segment our monkey object. We're going to call it monkey. That's going to be the category that we want to segment it into, and the color that we want to make it is monkey seg color. So that's going to be the color that we're going to apply to the object. All right, so let's group together all this stuff. So we got all of our monkey code, we got our saver code, and now let's go ahead and get a handle to the camera. So very similar to how we got a handle to the monkey, let's go ahead and get a handle to the camera. If we look at the outliner here, we see that the camera is called camera. So let's go ahead and save that as a camera. Save that to the camera object here. And then we're going to be doing some jittering with the camera where we move the camera around, and we want to be able to reset the position of the camera back to its original position. So let's go ahead and save the position of that. So zpy.objects.savePose, and let's save the position of that camera. Let's call it the original position. So that's going to save the pose, which is not just the X, Y, Z, but also the rotation along those three axes. And we're going to save that so that we can always return the camera to the original position if we want. All right. So now let's actually start running the scene. So what do we mean by that? So ultimately we want to take 10 images, right? We defined up here we're going to want to take 10 images. So why don't we go ahead and say for image ID in range num images. So this will go ahead and range is a Python function which will it'll return an iterable, which will basically give us 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then it'll end. So this image ID is going to start at 0, go all the way to 9, and then it'll exit this for loop. So at the beginning, before we take every single picture, let's jitter the camera. So jittering basically means moving the camera ever so slightly so that the relative position between the camera and the monkey are different. And the reason you do this is that you don't want all your data to look the same. You want it to be somewhat randomized, right? And you want the monkey to appear in the bottom of the image sometime, at the top of the image, in the middle of the image, so that whenever you actually train a model on this, the model is able to be robust to the location of the monkey. So let's go ahead and jitter the camera object, and let's say translate range and rotate range. So you basically provide a tuple here, a tuple of 3 tuples, where the inside is how much you want it to move, right? And you can click on an object here, such as the camera, and expand this part, and you see the location of it. So this camera is at 7, -6, 4. So you could ask yourself, how much do I want to move this in the X space? Well, if you hit G, you can move it. You can kind of maybe want to move it ±1, ±1 on the Y, and maybe ±1 on the Z. So it looks like we want this position here, but ±1. So let's go ahead and do that. We're going to say ±1 for all 3 of the axes. This is X, Y, and Z. And that is going to be our jitter. Make sure to close that parentheses there. And as we said before, we want to basically, we don't want to keep accumulating this jitter. We want to reset it before every image. So let's go ahead and objects, this is also objects, dot restore pose, and we're going to restore it to the original position. So each step of our simulation, we're going to return the camera to its original position. We're going to jitter it by ±1 in the X, Y, and Z axes. And now we can actually do the fun part here. So first thing we're going to do is come up with names. What are we actually going to call the color image? And what are we going to call the instance segmentation image? So we provide a nice little utility function here where we can make an RGB image name, and we're going to call this image ID. So this function, all it's really going to say is it's going to give you a string. Actually, let's go ahead and show you here. So you can always debug here. So in the Python console, let's go ahead and copy and say, what happens when you say ZPY files make RGB image name and you give it 1? It's going to give you a nicely formatted name here. It's a string, image underscore a bunch of zeros, 1 underscore RGB.png. So that is effectively what we're doing here. We're saying this is the name of the file that we're going to save. And there's also a function to get a iseg image name. So if we go ahead and test that call right here, image underscore a bunch of zeros, 1. Ooh, I I did not notice you guys cannot see that, so let's go ahead and move this a little higher. There you go. So you can see how this function call just returns a string that is the name of the PNG, and this one returns a similar string with a different ending. So now that we know what we're going to call our segmentation and our color image, let's go ahead and render the image. So let's say zpy.render and render AOV. Don't worry too much about the AOV part. We can explain that in later videos, but basically you're going to be rendering a color image, otherwise known as an RGB image, and then a segmentation image, otherwise known as an instance or ISEG image. So to let ZPy know that you want to save a color image, you want to give it a RGB path. And the path for this is going to be saver.outputdir, which is basically the output directory of this saver object. We can go ahead and change that if you want. The default output directory usually works pretty well. It's the temp folder, and it changes depending whether you're in Linux or in Windows or in Mac. It'll kind of pick a default one that makes sense, but you can always change that. Look into the actual initialization call for its saver if you want to see what the coorg for that is called. So we're going to go ahead and say we want to save a RGB image at the saver output path, and that's going to be the name of it. And let's go ahead and do the same, but with an instance segmentation. ISEG path, saver.output, dir, and we will call this ISEG image name. And we should also tell it how big we want this image. So we want to generate a 640 by 480 image. All right. So now we've jittered the camera. We've decided that the name of our image, and we've gone ahead and we've rendered this image. So now this image exists in our temp folder. But the saver object still doesn't know about this image. So let's go ahead and add this image to our saver object. Let's let the saver know that we've just created an image. So the name of this image is RGB image name. The style is default. Basically, you're letting it know that this is just a normal RGB color image. The output path is saver.outputdir /RGB image name. And the frame is image ID. So frame is effectively, you're saying it, if you had a variety of different cameras and you took a bunch of different images from those cameras, you want to be able to say all of these images correspond to the same moment in time, right? The same frame. Frame is a terminology from the kind of animation world in Blender, and it basically means instantaneous moment in time. And in this case, you're saying that this is the 0th image. And we also want to go ahead and say, give the width for this. So this was the width, and the height is 480. All right, so now we've added the color image. Let's go ahead and also add let's get rid of that space there. Let's also add the ISEG image, and this is a segmentation. Everything else is basically the same, except you're just changing the path. The instance segmentation, the frame is the same, the width and height are the same. All right. Now that we've added both of the images, let's go ahead and add the annotation. So let's add an annotation here, and this annotation is going going to say the image is RGB image name. That is the image where you're segmenting out an object. The seg image, so the segmented image, is iseg image name. So you're saying this is the color image, this is the segmented image, and the color of the annotation or the object that is in that is our monkey color from above. So monkey seg color. And the category for that is going to be monkey. Am I driving you guys insane with the double quotes versus single quotes yet? Okay, so we've gone ahead and we've created a saver object. We've gotten a handle to our monkey. We've added the category of monkey with its own segmentation color, and we've segmented the monkey. Then we've gotten a handle to the camera. Then we've saved the original pose of the camera. And then we're inside the actual generation loop, which we've decided is going to run for 10. So there's going to be 10 images taken total. At the very beginning of the simulation, we're going to restore the position of the camera. Then we're going to jitter the position of the camera so that there's a little bit of variance. Then we're going to say this is the name of the color image and this is the name of the segmentation image, which is based on the image ID, which we decided here is going to be a number from 0 to 9. Then we're going to go ahead and tell ZPY to render the image and put the image in this output path and render the image at this size. Then we're going to go ahead and add those images and an annotation for the monkey to the saver. So the saver is the actual JSON, if you want to think of it like your Cocoa JSON, your object that contains all the metadata about each of the images. So we're letting it know that there's a color image at this path corresponding to this frame. There's a segmentation image at this path here corresponding to this frame. And finally, there's an annotation that links this color image, this segmentation, this color within that segmentation, and this category within that. Okay, so that is the end of our for loop for recording the data. Now let's go ahead and output these annotations. So there's a couple different calls here. We can say output annotated images and also output meta-analysis. These are somewhat boilerplate calls, but basically they output a couple nice visualizations whenever we actually generate our data set. The important one here that you guys want is output Cocoa, and this is going to be Cocoa. We're going to give it our saver object, and we're going to ask it to output annotations. And we're going to do the same thing, but also in Zumo format. So ZPY has a variety of different output data types that are supported. Right here, we're interested in Cocoa and Zumo, which is our own internal format based on the Cocoa format. And these are dataset formats and annotation formats that are fairly common in detection and segmentation tasks. And basically, we will continue to keep adding different annotation formats so that you can always output your annotations in whatever format you want. All right, so this is the basic script here now. Let's go ahead and run it now. So let's hit save here, Control S, save it here, this is fine. All right. To run this, you can go into the Layout tab or in the Scripting tab. If you open this side panel here, this is also the end panel. You can hit the N key to get that panel out. So let's hit the N key here. If you have properly installed ZPY, you will see a ZPY tab there. There's a variety of different things here. We are not going to worry about almost any of these except for the script section. We will be doing other tutorial series about how to use the segment and the render and the scene export functionality, so stay tuned for those. When running Blender scenes, you want to be able to see, so go ahead and go to Window here and click Toggle System Console. What this does is it allows you to see the, where is it? Where is the system console? There it is. So this allows you to see the output. All of our ZPY functions here, and generally whenever you run Python code in Blender, it will output to the standard out in Linux, but here, because this is a Windows environment, it will output it. You have to open this console here in order to see the output. So we will go ahead and click save, and because this is a live demo, I'm going to hit run here, and it's probably going to error out, but we will see. Let's see if we are lucky. So let's hit the run button. Missing one positional argument, pose name. Let's see what's happened here. Save pose. Okay. So right here in the ZPY object restore pose, you have to say, I want to return the camera to the pose called original position. So that's what that error is. Let's go ahead and hit enter here and hit run. All right, so now we are going ahead and it's rendering. So these printouts here are Blender's printouts, and they're generally not very good. A lot of times they tell you there's a bunch of errors when there's not errors. We have logging utilities, and this scene will be made available for download, and the version that we have available for download will include some additional logging utilities so that you can have some pretty prints to look at. Okay, no annotations found. So let's go ahead and if you go to the render, you can open the temporary directory which was used to output these images. So if we go ahead and open that, we see that here is our beautiful little data set. Let me close this. So here are 10 images, right? That's our little image right there, our monkey. And we see here that the problem is that the segmentation images are completely black. So what does this mean? I know what this means because I've run into this error before, but basically what's happening is that whenever you segment an object, the object needs to have a material. And Blender itself, whenever you create an object such as this, whenever you create a default object like the monkey, it doesn't actually have a material on it. So let's go ahead into the shading tab, click on this monkey, and add a material to it. So now this monkey has a material. We can kind of change it. Let's make it let's make it a purple monkey. Purple monkey, let's make it actually have a lot of specular, very low roughness. So that is our little monkey. If you go back to the layout tab, you can actually hit this to see what it looks like with the render. Our beautiful little monkey. All right, but now that our monkey has a material, we should be able to go to the ZPY tab. Let's minimize these again. We can open this directory. Let's go ahead and hit clean. So whenever you hit this clean button here, it'll get rid of all that. So our output directory is empty now. And you can always change it by changing this path here. And let's go ahead and run the script again. So we run the script, the scene will freeze. Basically, unfortunately, the way that Python works with the global interpreter lock, while you're running Python code, Blender itself is just going to sit there frozen. That's why being able to see the window on the side here, can be very useful. So you can actually verify that your program is running and Blender hasn't just completely crashed. All right, it's rendering images. It's on image number 4, image number 5, image number 6. So you can see how this is actually cranking out images step by step, saving them in the output directory, and writing an annotation file in tandem. All right, so looks like it has finished. Our scene is responsive again. Let's go ahead and open the output directory. And there we go. Now our segmentation images are correct. So that is that blue color that we guessed. And these are the color images. So you can see they match up. Now let's go to the actual annotation files here. Let's open with text, of course. Possibly the worst program to open with. Notepad. And here is your Cocoa annotations. So if we go back to the scripting tab here, and then go to this, you see that the description is copied here. The info, the path to which this was saved, any image licenses. There's only a single category. Let me zoom in here a little bit. There's only a single category in this data set. It's just the category known as monkey. And there are going to be 10 images, right? All from 0 all the way to 10, or 9 because it's 0 indexed. And then there's going to be one annotation per image. The annotation has a bounding box, and it has a segmentation map or segmentation polygon, which is pretty long, right? Because it's basically tracing out the entire monkey. And that is your Cocoa data set. We also provide it in Zumo format. If we go into this hidden Zumo meta folder, this is kind of the secret sauce. There's always a Zumo meta folder in a ZPY generated data set. And here you can see annotated images. So this is basically the color image with the bounding box superimposed. And you can look at things such as the color correlation plot. So what is the red to green pixel correlation, the red to blue pixel correlation? There's also histograms. So out of all the annotations, how many are there per category? In this case, right, there's 10 total annotations over all 10 images, and all of them are monkey. And image shape plot, so what is the width and the height of all the different images? Here, all the images are 480 by 640, so it's just a single dot. And these type of plots can be useful when you're generating more complex data sets and you want to kind of understand, are the classes balanced? Is the categories correct? Are the annotations looking good? For example, here, the pixel histograms, we can see that most of the pixels, almost all the pixels, basically all the pixels in the images are very narrowly kind of distributed, which is easy to think about because really there's only, that's all of them, right? Every single image is either basically this gray color or these different shades of purple. All right, so that is the tutorial, guys. Thanks for watching this entire video. We, just as a summary, we created a simple Blender scene. We scripted that scene with Python and ZPY, and we used that to generate a very small, obviously very toy synthetic data set for detection of monkeys. Stay tuned for more videos in this series. We're going to take you guys through the entire process, everything from creating this simple scene, then doing some more complicated things such as changing the textures and changing the lighting and adding other types of domain randomization, and then how you can use that data set to train an object detection model that you can then deploy in a real-world scenario. And it's going to be exciting. Check us out at zumolabs.ai. Check out the GitHub. give us a star, and open up an issue. We're early. This is an MVP product. Give us feedback. We are always on the lookout for more feedback. Thanks everybody, and have a great day.